Welcome to the two-step equation solver from CSandMath.org. My name is Ashley Tavis, one of the co-founders of the website. If you haven't checked out our resources before, both Mike and I's goal is to help students become college and career ready through implementing coding into our math classrooms. Not only does this allow students to work with the fundamentals of coding, but it also allows for a deeper understanding of key math concepts. We have found in order to get the full experience with our lessons, it works really well if you pull open another tab and you create your own program while we teach ours. That way you're kind of putting yourself in the role of the student and you can experience the power behind this work, just as they would in your classroom. I hope you enjoy our two-step equation solver lesson and find success when you bring this into your own classroom. The first piece of understanding your kids will need as you start this program is that a two-step equation is typically formatted as ax plus b equals c. So understanding that a, b, and c are just different inputs that the user could choose in this program, as we would create many different two-step equation problems. So the first thing I would do as teaching this lesson is put up maybe this slide on the board and ask students, what do you notice, what do you wonder? So you'll see, if we look at this first box, there's a one solution with two equations here. There's a no solution with two equations, infinite solutions with two equations, and x equals 0 with two equations. Now, as you give students time to think about this, maybe start by them thinking independently and then allow them to do some pair share thinking together, and then come together as the whole class, validate all the answers, but the goal is that you should arrive with this pattern recognition, these four computational key concepts. So decomposition, algorithmic thinking, abstraction, and pattern recognition. This last slide we looked at validates the pattern recognition they can understand through looking at different two-step equations. So what we hope that they'll come to eventually, maybe with a little bit of guidance from the teacher, is that one solution problems we'll notice here, as we do c and we subtract off b, we are not equal to 0, our values here. 11 minus 3 does not give us 0, 8 minus 4 does not give us 0, and the a values are also not equal to 0. In our no solution, we've got a similar idea here, that c minus b does not equal 0 in both of these cases, but a does equal 0. And when this happens, a no solution will occur. Our infinite solutions, we'll see here c minus b does equal 0, and a also equals 0. And finally over here, we've got c minus b equals 0, and a does not equals 0 will give us a value of x equals 0. These are going to be really important patterns to recognize as a class together before you launch into your program. So the next thing I would do with kids to lead them into the code is create some sort of flow chart representing these ideas that we just saw, these patterns we recognize. So the first kind of branch I would do off of this flow chart is when c minus b equals 0 and when c minus b does not equal 0. So let's start on the left-hand side here. We said if c minus b equals 0 and a equals 0, we're going to have infinite solutions in our equation. If c minus b equals 0 and a does not equal 0, x equals 0 is going to be our solution. Finally, over to the right, if c minus b does not equal 0 and a equals 0, we'll have no solution. If c minus b does not equal 0 and a does not equal 0, we will have one solution to our equation. Now, I wouldn't give kids this answer, we would set this up together. But this is the spot that they should get to before they jump into actually using Scratch. Now it's time to transfer our program to code. So the very first thing you'll want to do in this program is create a handful of variables. You will find variables under the Data tab here in Scratch. So the first variable let's create is a, b, c. We're going to need c minus b as we saw in our patterns that we created. Let's create a variable for x, and let's create a variable for our equation. Now you'll notice as these are checked on your screen, they're appearing on the left. I am actually going to uncheck all of these values so they disappear from my main screen. Now the very first thing to start our program is we're going to drag over our when the green flag is clicked. This is typically how you start a program in Scratch. As when you hit the green flag, the program starts. When you hit the red stop sign, your program will stop. So the first thing we're going to do is just set our values of a, b, and c to themselves, and this will make a little bit more sense as we launch deeper into the program. So you'll notice these drop-down tabs, and we can type anything into these white boxes. Now, typically, it's nice to start your program explaining how this is going to work. So, for example, welcome to the two-step equation solver. That's how I'll start my program in terms of directions. Now, the next piece is going to look a little bit complicated, but we'll work through this piece by piece. So the first thing, in sensing, we're going to drag out an ask block. And this is really nice in Scratch because this feature allows users to type in values that they want to be run and manipulated in this program. So what we're going to ask here is we're going to pull out some of these join blocks, and we're actually going to use 5 of them. So you'll notice these just clip into each other here. And for the sake of seeing this a little bit better, I'm going to make that smaller. And the first thing we're going to do is we're going to join our letter A with x equals, join our letter B with an equals, and join, we need one more in here, I only put out 4, join our letter C, and then we're going to ask, we're going to do some spaces. We're going to say, what is A? And I'm going to clip this in here, and I want you to notice what this will look like as I run this program now. So notice, oops, my one mistake is we need to come in here and make this A plus. Now as we run this, you'll see AX plus B equals C. What is A? So although this join piece looks a little bit complicated, what it does for us is it allows a really nice format here as we type in inputs. So now, once they choose a value for A, we need to set A to the value that they type in. So whatever they type in using this ask block is stored in the answer block. So we'll store this here. Now, I'm just going to 2-finger tap this or right-click and hit duplicate to save us a little bit of time here, because the only thing we're going to adjust now is say, what is B? Set B to the answer. And finally, what is C? And set C to the answer. Now notice how this will run. As I type in a value here like 3, it's now replaced in my equation. 4 replaced in my equation. 10 replaced in my equation. So now I need to display this equation at the end here. So I'm just going to say here at the end, I'll duplicate these green pieces again. I want to say all of these values here without asking for a value. So at the very end, it's going to display this equation for us. This is all just kind of formalities and kind of making your program a little bit fancy. Next, we need to set our equation to this say block as well. So now our equation is set to the values that the user has typed in. And next, since we are going to use C minus B quite frequently in our program, we're going to program this using the operators. So we'll set C minus B to C, the value of C they typed in, minus B. Perfect. Now we're ready to jump into more of the math and the understanding of patterns. This is the part of the code where the true mathematical thinking and pattern recognition comes into play. So to find success in this part of our code, we're going to want to think back to the flowchart we created together. So to break this into our first 2 branches of C minus B equals 0 and C minus B does not equal 0, we're going to use this if then else block under the control section. So I'm going to pull out first off an equal sign, and then my subtraction. I'll put my 0 here, and we can either use C minus B equals 0 or our variable C minus B we already created. Either one's going to work great. So this could be a good pause in your classroom to talk about what is an if then else block doing for us. You could do something like, if you're a girl, go stand on this side of the room, else go stand on the other side of the room. Or if your birthday is in September, go stand on this side of the room, else go stand on this side of the room. So this could be a really good spot to kind of understand what is this block doing for us. Because as we read this, up here is talking about when c minus b equals 0, and the else is talking about when it is not equal to 0. Now the next distinction we had in our code was if a was equal to 0. So again, we're going to drag out our variables here. And now if we look up at this setup, we'll see this is reading as follows. If c minus b equals 0, under here, now we want to know also, does a equal 0? Then something should happen. If c minus b equals 0, but a does not equal 0, something should happen here. So this looks really long, but if you follow your flow chart, this should fit nicely. So the first thing we're going to want to put in here is when c minus b equals 0 and a equals 0, we said there are infinite solutions. So there are infinitely many solutions to your equation. And when c minus b equals 0, but a did not equal 0, we said x is equal to 0. Now finally down here, to when c minus b does not equal 0. When c minus b does not equal 0, but a equals 0, we said there are no solutions to your equation. But now down here, there's going to be one solution. Now how could we program this? Let's set our x value to c minus b divided by a, and now my x is programmed to our one solution. And finally, we can say our one solution using a say block. And pulling out a join block, this combines just different strings and variables. So we can say the value of x is, and now we can drag in our x variable that we just programmed together down into this piece here. And this should complete our program. So this looks really long and daunting as you look from the start. Keep in mind right here was just kind of a fancy piece to our program to set this up nicely. But the heart of the math and the pattern recognition happens as we get into these if, then, else blocks.
We would love to hear your experience with using this program in your classroom. Here's a glimpse at some of my students as they created this last week.
When I started my program, it was a little hard, but then I kept trying different things like trial and error, and I finally stuck with it, and I was very proud of myself. I enjoyed creating this program because it was fun experiencing the different characters and the different sprites.
Minecraft Aftermath. And then so all I did was a bunch of trial and error, put some code and try it. If it fails, try it again until you get the right code.
How did you feel when your program finally worked after your trial and error?
I felt great and refreshed. It's almost like I just slept for 8 hours.
Coming to a new school, I had never heard of Scratch before. I had done programming with other languages, but Scratch was completely new to me. And I had a very awesome project from CSandMath that dealt with two-step equations, and I love the idea of connecting coding to algebra. So, a little nervous, but I knew the students had looked at Scratch before, so I basically brought the challenge to them, and then as I walked around, I could kind of see their thinking, and they were kind of teaching me one by one. So if I saw student A doing something for step 1 and student B had help, I could kind of have student A go help student B, and then I'm the whole time observing. So by the end of period 1, I felt like a pro in Scratch just by watching students who had already done Scratch. Because the experience of the collective really helped the individual for these types of problems. As a whole, we started out class with Scratch. So I would probe a little bit, and it turned out that one student didn't like it because he wasn't good at coding yet. But by the end of class, 90% of the class left happy, feeling like, I finally get it. It finally makes sense. I love the challenge of giving them something where it feels like they're never going to solve it. But then as class goes, by the end, they felt so great creating a program that acted as a calculator.